Hi everyone, welcome to my channel. My name is Thirumavalavan Srinivasan. In this video, I will show you how to create Amazon Aurora database on a custom VPC. Let me quickly introduce about myself. My name is Thirumavalavan Srinivasan. I have over 18 years of IT industry experience. I'm also an AWS community builder on machine learning category. And currently I have 11 AWS certifications. These are the AWS certifications that I currently hold. I'm also an ex-AWS partner AI/ML Black Belt. I'm also an ex-AWS partner ambassador. I think that's enough introduction about myself. Let's quickly look at Amazon Aurora features. Amazon Aurora is a MySQL and PostgreSQL compatible enterprise class database. Amazon Aurora has up to 5 times the throughput of MySQL and 3 times the throughput of PostgreSQL. Amazon Aurora has 128 terabyte of auto-scaling SSD storage. It was 64 terabyte earlier. Now it has been increased to 128 terabyte of auto-scaling SSD storage. That's cool. And Amazon Aurora has 6-way replication across 3 availability zones. And Amazon Aurora also has up to 15 read replicas with a sub 10 millisecond replica lag. Now, Amazon Aurora has automatic monitoring and failover in less than 30 seconds. I think that's enough introduction about Amazon Aurora. Let me introduce to the architecture that we are going to implement in this video. So this is the architecture that we are going to implement in this video. We are going to select a region. For this demo, we will use East 1 region, and in this region we will create a VPC, custom VPC, and we will create 6 subnets, and we will have 2 of them as a public subnet. That means we will have the route table associated with the subnets that goes to the internet through the internet gateway, and we will have 4 subnets that doesn't have any access to the internet. They are private subnets, but we will create a NAT gateway in one of the public subnet, and we will attach it to the route table for any if you need to access the internet for updating the patches, or for anything, for any traffic that originates from the within the private subnet, like if we need to for accessing or like for updating the patches or firmware, we can do that using NAT gateway. But we cannot access the resources that are on the private subnet from the internet, because we will completely block that. We will not have it attached with the internet through the internet gateway. So in this architecture, you can see that like we have a bastion ghost or jump host, that jump box that I'm going to create on the public subnet. I'll connect from my local system to the bastion host or jump box that we are creating on the public subnet. And then we will create another EC2 instance on the private subnet. We will call this as an application layer, and we will not have any public IP address or anything. So we will have only private IP address, but we can connect to this private EC2 instance from the bastion host or jump box. And once we connect to the private EC2 instance, and we will have that Aurora database that we will create on the database layer. Here in the layer 3, it's a like multi-tier architecture. In the layer 3, we will create Amazon Aurora database on multi-AZ deployment. We will have it like writer instance on one availability zone, and the read replica on the another availability zone, and we will be able to connect to this database from the private EC2 instance. So I will walk you through step by step and then show you how we can implement that. Let's log into that AWS console, and I'll walk you through that. I have now logged into the AWS management console. I'm at the console home now. Let's quickly go to that VPC. If you have already visited VPC, it should be available here. If not, you can just type VPC. I'm going to create and open it in the new tab. And currently we have one VPC, but that is default VPC. And you can see that IPv4 CIDR range is 172.31.0.0/16, and it says default VPC. Yes. So we are going to create a custom VPC. Let's go ahead and create one. So we can do it two ways. Like we can just create VPC only, and then we can create the other components like creating internet gateway, attaching it to the VPC, and then creating the subnets, and then creating the NAT gateway. And if we want to do all that one by one manually, I have already created a video for that, and I'll give you a link for the video in this description, and that will explain you how to create the VPC and all other VPC components manually one by one. But for this demo, let's go ahead and select this one, VPC and more. So here you can see like the VPC will be created, and then we will create the subnets, and then the route tables and network connections, everything. So it's auto created. Like this is cool automation that AWS has introduced recently. This is nice. And let's leave that prefix for like name tag. Let's auto generate with the project. So you can see everything is prefixed with project dash VPC and project dash subnet public 1 and US East 1. The region that it is going to create the subnets. So for the route table also it says like project dash RTB for route table dash public. So that's good. And for IPv4 CIDR range, let's go ahead and use the same one like 10.0.0.0/16. That's perfectly fine. And we are not going to create any IPv6 CIDR block for this one. That's fine. And the tenancy, we are going to leave it as a default. And the number of availability zones, we are going to have two. Like if you remember the architecture, we are planning to create subnets on two availability zones. So let's leave it as two. And if you need to customize or change the availability zones that we want to create, you can change that here. But let me leave it as US East 1A and US East 1B. That's perfectly fine. And here, number of public subnets, like if you remember in our architecture, the green subnet boxes, we had two public subnets. So let's leave that as two. But on the private subnets, we wanted to have four. If you remember, two for the application layer, where we created the private EC2 instance, and two for the database layer, where we created the Aurora database. So let's go ahead and select four here. See, the moment we selected four, it has added two more. Like let's change it here. Say it's changed, and then if you see 0, no private subnet, but we need 4. So we have totally 6 subnets, 2 public subnets and 4 private subnets. And for our demo, we need a NAT gateway. NAT gateway costs money, like because we need to have elastic IP address associated with that. So be careful if you need to use NAT gateway. And like if you are done that, please remember to delete NAT gateways, or also release the elastic IP address, otherwise you'll be charged. So we don't need to create NAT gateway one per the AZ. That's a high availability solution. But for now, for this demo, let's do it with one AZ. That's fine. So the moment I say that here, see here for the network connectivity, it's just like, that internet gateway that is attached. So for public, the route table, the subnet that is associated with the route table for the public, it is associated with the internet gateway. But the moment I create NAT gateway, so it is going to create a NAT gateway here, and all the private subnets that are associated with the private route table, that will point to the NAT gateway for any outgoing internet connection, for firmware update or anything, for any request that originates from the private subnet. And we are not going to create VPC endpoints. We don't need it. So see, it says currently it says that it's going to create VPC endpoint for S3 gateway, but for our demo we don't need it. So I'm going to say no, and that has been removed. So this is a cool, visual representation. This looks good. Like this is the VPC that we are going to create, project VPC, and all the 6 subnets and the route tables, and then whatever that network connections that we are creating, internet gateway and the NAT gateway. See, if you select the internet gateway, that is associated with the project or route table, public route table, and 2 subnets that are associated with that, one from each availability zone. It's just like project subnet public 1, project subnet public 2, US East 1A and 1B, that is associated with this route table, and this is associated with the internet gateway for network connections. So it means we can access the resources that are created on the public subnet from outside the internet. And for the other 4 subnets, you can see that it is associated with the NAT gateway here. 1, 2, and 3, 4 subnets, and it is associated with the private route table. Once it is created, I will walk you through and then explain everything. Let's go ahead and create the VPC. It's going to take some time. Let me pause the video and come back once all the resources are created. Okay, now all the resources has been created, and you can see that like creating VPC, DNS hostname, DNS resolutions, and creating all the subnets, and creating the internet gateway, and attaching the internet gateway to the VPC, and creating the route tables, and then associating the route table, and allocating their elastic IP address, and then creating the NAT gateway, and then that will be associated new elastic IP address will be associated with the NAT gateway, and all those things. You can see that. Let's go ahead and view the VPC. If you click here on the VPCs, currently we have 2 VPCs. This one is the default VPC that was already available on 172.31.0.0/16 IPv4 CIDR, but this is the project-VPC. If you remember the prefix for the name tag that we gave project-VPC is newly created on 10.0.0.0/16 IPv4 CIDR range, and this is not a default VPC, it's custom VPC that we manually created now. And let's go to subnets. Let me filter it with the VPC ID, and let me expand it here a little. Okay, you can see that we have 6 subnets that are created and associated with the project VPC, and the IPv4 CIDR for each subnet, and the availability zone it has been created. So this is the subnets, and let's go to route tables. And if you see the route table also, let's filter it with our if you see, we have created a project route table public. This is the public route table, and then if you see the subnets that are associated with it is the 2 subnets that are associated. So project subnet public 1 US East 1A and project subnet public 2 US East 1B. These 2 subnets, these are associated with this route table. And if you see the route, this is the default route 0.0.0/0. Sorry, this is the route for the internet that goes through the internet gateway, and this is the local route of any resources within the VPC they can communicate within each other. So that is 10.0.0.0/16. This is the local route. We cannot edit or modify anything. This is the default one. And since we have created internet gateway and attached to the VPC, and any traffic to the internet, that is 0.0.0/0, that goes through the internet gateway, and any resource that we create on these two subnets, that will have access to the internet. So that's why these are called public subnets. The other four subnets will not have route to the internet through the internet gateway. That's why they're called private subnets. Let's see one by one. So let's see project route table private 1. So the subnet that is associated with this is project subnet private 1 is US East 1A, and the route, if you see, for the internet, it uses the NAT gateway, not the internet gateway. It means we cannot access the resources that is created on these subnets from outside the internet. We cannot initiate a connection from the internet to connect to the EC2 instance that is created on this subnet. So if the instance that is created on this private subnet, if it needs to talk to the internet for any patch update or anything, so that request will go through the NAT gateway. So it doesn't go through the internet gateway. And this is the default local route. So that's the same for all four private subnets. You can see this subnet associated with this one, and the route goes through the NAT gateway. Next one. So this is the subnet that is associated with it, and the route goes through the NAT gateway. And this is the subnet, and then the route. See, it goes through the NAT gateway. So all of this has been automated now. So if you see that we have used the new wizard to create VPC and more, and we have created everything automatically. So if you need to create it manually, I already have created a video for creating all the components, VPC and other components manually, and then how we can, connect it. I'll give a link to that video in the description. You can do that, if you want to do it one by one manually, if you don't want to use this new automated feature. So that will help you in learning the components. But once you get a hang of it, so if you want to create all these components quickly, you can make use of this new feature that AWS has introduced, that VPC and more. So everything has been created. Now let's go to the internet gateway. So the project internet gateway, you can see that is attached to the project VPC. And if you go and see that elastic IPs, see if we have an elastic IP address that is allocated for us, and that is associated with our NAT gateway. And we didn't create any endpoint. We said no for that. And NAT gateway, yes, we created one. We didn't create in each availability zone, just we created in one availability zone. And so it is created only one on one subnet, that is project subnet public 1 US East 1A. So this is the subnet that it has created, the NAT gateway. And I'm not going to go in depth about the network ACLs and the security groups. So as I have mentioned, please refer my other video where I have talked in details about NACLs and the security groups and all other components within the VPC. So the link will be in the description. I think that's about it for now. Let's go ahead and create the resources that is, as per our architecture. So first we need to create a public EC2 instance. For that, let's go to EC2. If you already accessed EC2, it should be available in the recently visited tab. If not, just type for EC2. I'm going to open it in the new tab. So we don't have any instance at the moment. So I'm going to launch the first instance, that is Bastion host or jump host, on my public subnet. So um, I'll just name it as a Bastion host. I'm going to use Amazon Linux. That's good enough for now. And instance type, let me go ahead and select T2 medium. And key pair, let me see if I have created, I don't have a key pair. Let me create a new key pair. So we need a key pair, and I'm going to use putty. So let me select .ppk extension for putty. Earlier this option was not available. We have to create .pem file, and then you have to convert it for putty to use for .ppk. Now it is available. I'm going to name that key pair name as EC2 key pair. That's fine. And it has been created and downloaded, and it is selected EC2 key pair. That's good enough. And network settings, and I'm going to edit it here because I don't want to create this Bastion host on the default VPC. I want to create it on our custom VPC, that is project dash VPC. So let's select the newly created project VPC, and the subnet, let me select project subnet public 1 US East 1A. So that's as per our architecture. And autos and public IP address, yes, we need public IP address because it's the Bastion host that we are going to connect from our local system, and it needs a public IP address. It's in the public subnet. We need to connect to it from our local system via internet. So we need that. So set it as enable. And security group, let me create a new security group. Let me say Bastion host security group, and just use the same for the description. For SSH connection, to connect to this one, I'm going to for now set it as anywhere. We can do it like custom or my IP address, and that is always recommended. But for this demo, I'm just going to use anywhere, and after this demo is done, anyway, I'm going to delete the resources. So that's fine. So let me just leave it as anywhere as a source type, and then the type of the connection is SSH. And please do not do this on the protection environment. You need to select it to your custom IP address or some custom rule. You may want to set that. Do not leave it as wide open. So that's fine for on port 22. On advanced network configuration, I don't think we need to make any changes here for this demo, and then I'm going to leave that storage as it is. And let's see if there is anything if we need to do it here. I'm not going to do a spot instance. I think everything else should be good. Let's quickly review the summary here. We are going to create one instance, and that is Amazon Linux 2 kernel, and the server type is T2 medium, and we are creating the new security group for SSH connection, and I'm going to launch the instance. Okay, now this is created. Let's go and view the instance. So it is getting created now. So while we are waiting for this one, let's go ahead and create one more instance as per our architecture on the private subnet that we can use to connect to the database engines. So let's launch one more instance. And name, I can do it private EC2. I think that should be fine. I'm going to use Amazon Linux, and same thing here, and let me go ahead and select T2.medium, and key pair, I'm going to use the same key pair, EC2 dash key pair, and again edit the network settings and select the custom project VPC, project dash VPC, the new one that we created. And for the subnet, we don't want the resource on the public subnet. We want it on the private subnet. If you remember, like we had 6 subnets, 2 public subnets and 4 private subnets. And like, we have created on 2 availability zones. So it's like, we are going to use the application layer. For that, I'm going to select private one, project subnet private one, US East 1A. That's good. And we are going to leave it as autos and public IP as disable, because this instance we are creating on the private subnet. So even if we have a public IP address, we will not be able to access it, because the route table that is associated with this subnet doesn't have an association with the internet gateway. It it associated with a NAT gateway for any outgoing connections. So we cannot have any incoming connections from the internet. We cannot initiate it. So let's leave that as a disabled. And we are going to create another security group. Let me name it private EC2 security group. And let's use the same for the description. No. Okay. And for this one, I'm going to have all traffic, but the source type I'm going to say is custom, and I'm going to select the security group, that is Bastion security group. So if you remember, for our jump box or the Bastion host that we created on the public subnet, we used the Bastion host security group. So for this private instance, we are going to allow all the traffic that comes from the public Bastion host to the private host instance. So I'm going to select Bastion host security group here, and that will allow all the traffic. So we are not going to make any more changes here on the storage or network configuration. Let's review the summary here. Number of instances, it's 1, and it's T2 medium, Amazon Linux to kernel, and everything else looks okay. Let's go ahead and launch the instance. So when this is getting launched, view all instances, let's go and see. Now the Bastion host is created, it's an up and running. Let's go and quickly look at it. So it has a public IPv4 IP address, and it has both private address and the public IP address. And we can see the security group. So we can access it from the internet, SSH connection on port 22. That's fine, and everything else okay. So let's go ahead and connect. Now that private EC2 instance is also created and it's up and running fine. Let's quickly see that one, and it says instance status running, and it doesn't have any public IPv4 address, and it's private IPv4 address. This is the private address, and it's in T2 medium and on project VPC. And this networking, if you see subnet, it's project subnet private 1. Yeah, that's what we have selected. And if you see this security, and any connection that originates from the instances that has the security group as the Bastion security group, and that will have full access. So basically it means that we will have full access to the private EC2 instance from the Bastion host or the jump box. So let's go and connect to the Bastion host. To connect to this one, let's select the Bastion host and then say connect. So it's going to give us the option that how we want to connect to it. So you can do that like with this IP address, and username is EC2 user and SSH client. If you want to do that, this is the way we will do it. And so let me go ahead and copy the public IP address for this one. Copy the public IP address. I'm going to connect it using the putty session. Okay, let's connect to the Bastion host using putty. So here we are connecting the username ec2-user at the public IP address 54.86.104.51, and let's go to SSH and authorization. And here if you see, I have selected that key pair that we have created, ec2-kp.ppk file that can be used on putty. And also we need to select this checkbox, allow agent forwarding. If you don't do that, we will not be able to connect to the private EC2 instance from the public EC2 instance from putty. So this will help us, use the same key pair from our local system without copying the key pair on the public Bastion host. And we should also execute that SSH authentication agent for putty and add the keys. And I have already, here you can see that, like, putty SSH agent key list. I have added that EC2-KP for the key pair. So if we have this, and if you select that allow agent forwarding, that's good enough. We don't have to copy the key pair to the public Bastion host to access it, access the private EC2 instance from it. So I'll show you. And this is good. Let's give open. It is connected on my other window. Okay, so here it is. Let me expand it later so I can see it properly. Okay, so we have connected using EC2-user username, and we have connected to the public Bastion host or jump host. From here, we need to connect to the private instance. So let's go and get the IP address for the private EC2 instance. This is the private IPv4 address. Let's copy it and let's bring the partition and let's do SSH here. SSH EC2-user at the private instance IP address. Let's copy it twice. Let me just copy it once. Yep, it's there. Like if you remember, to connect to these instances, we need to give SSH and then -i and then that key pair file. We need to give that and then the username and the IP address. Since we have enabled that SSH agent forwarding, we don't have to copy the key pair onto the public instance. So so we can securely use that from our local system. So I have that key pair on the local system and I have enabled that SSH agent forwarding. So once I click enter, say yes, and we are now on the private EC2 instance now. And let's install SQL client here. And if you use yum install MySQL, it will install that SQL client onto the private instance. If you remember, we have created the NAT gateway on the public subnet, and we have associated the route table for the instances on the private subnet to connect to the internet using NAT gateway, not the internet gateway. So if the request is initiated from within the subnet, from the private instance, so we can connect to the internet and get the SQL client installed. Good. I need to be root here. Sorry about it. let me change to root, and now let's install SQL client. Yep, say yes. Yeah, true. So we have installed the SQL client on the private EC2 instance. So now the last step is creating Aurora database on the database layer and connecting to the Aurora database from the private EC2 instance. Let's go to the AWS console, and let's go to RDS. If you don't have it on the recently visited, please type here and then go to the RDS console page. So I'll right click and then I'll open link in the new tab. So yeah, now we are in that Amazon RDS console, and if you see the databases, we don't have any databases here. And before we create a database, let's create the subnet group where we want the database engines to be created. So click on the subnet groups. Currently we don't have any subnet group. Let's create a DB subnet group. Let's name it my Aurora DB subnet group. Let me use the same for the description here, and select the VPC. Let's select the project-VPC, and let's at the subnets first, let's select what the availability zones we need. We have subnets only on ES East 1A and 1B, so we are selecting both here, and we need to select the subnets, but this will be a little confusing. We will not know which one is the public subnet and which one is the private subnet. Let's quickly go to the VPC console and go to the subnets page. Let's filter it with the VPC ID and the project VPC, and let's expand it here a little and see uh, the name tag project subnet. It has public 2 and public 1 private. So for our database layer, it's the last one. So we have 4 private subnets: private 1, private 2, private 3, and private 4. So we need to create a subnet DB subnet group on private 3 and private 4. If you see, private 3 is on US East 1A, and private 4 subnet private 4 is on US East 1B. And if you see the IPv4 CIDR range for both of them, it is 10.0.160.0 and 10.0.176.0/20. So these are the two sub IPv4 CIDR range. If you remember that, we will know that is private 3 and private 4. So it's 160, 176. Let's go back to ODS management console, select subnets, and let's select 160 and 176. So these are the two subnets. Let's double confirm it. Yep, 160 and 176. Okay, 10.0.160.0/20 and 10.0.176/0/20. So these are the two subnets, the private 3 and private 4 subnets that we can use for a database layer. And let's go ahead and create it. So it's created now. Let's go to databases. We don't have any database. Let's click on create database, and by default Amazon Aurora is selected. That's what we are going to create. So, and let's not use easy create, and let's do the standard create, and I'll walk you through the process here. And for that edition, we are going to use MySQL compatible edition, not the PostgreSQL edition, for this demo. And for the engine version and engine filters, you can see that if you select the filters, and if you want to see that supports the global database features, you can select that one, and you can see that instances. Or if you want see the versions only that supports parallel query feature, you can select this box, and then be that. Or if you do that, want to show the versions that supports serverless version 2, if you select that, See, the list is very few, like, just two instances, two versions are available. So let's not do any of that here, and I'm not going to select anything. I'm just going to use, the default one, Aurora MySQL 5.7 version. That's good enough for this demo. And I'm going to select a protection here, and a DB cluster identifier. I'm just going to say my Aurora cluster, and for the credentials, that username, let me leave it as admin, and I'm going to create a password. I'm not going to use the password. Yeah. um, and I'm going to confirm a password. Ah. Okay, I think I correct. I used it correct one, and the confirm password. And our DB instance class, by default it's selected memory optimized class. If you want R classes that is memory optimized, say DBR5, DBR5. Now, if you want that DBR5 12x large 16, so we can use this one. For our demo, I'm not going to use memory optimized classes. I'm just going to use burstable classes, and that should be available. And if you go for a higher configuration instance, sometimes it may not be available on the region or the availability zone that where you are going to create it. So for now, yeah, let me select, okay, T3 medium. That's good enough for me. And on availability zone, and it says like a multi-easy deployment. There are two options. One is to not create an Aurora replica, and one is to create a reader in replica. But we have in our architecture, if you remember, we are creating multi-easy deployment, and we have a writer instance and one availability zone, and the read replica on the other availability zone. And we have a DB subnet group also created on two availability zone. So I'm going to use leave this box, create an Aurora replica or reader node in a different AZ. That's perfectly fine. And here is a cool thing. There are two options for compute resource connectivity. If you see, by default, it says don't connect to an EC2 compute resource, and the second option is to connect to an EC2 compute resource. This is a new feature, so this is cool. If we select this one here, and we can, you know, select our private EC2 instance. By default, when the instance is getting created, it will automatically create the security group and the rule, everything, and attach it to our private EC2 instance, and we'll be able to connect to the database engine from the private EC2 instance. We don't have to manually create a security group or allow the connection, open the port, on the security group. We don't have to do that manually. Even if you don't do this step now, you can do it like once the database is created. We can create connectivity to the EC2 compute resource. We can do that later as well. So for now, let's go ahead and select this one, connect to an EC2 compute resource. So if you do that, it will ask which instance you want to do that. So obviously we don't want to connect it from the Bastion host. We want to secure the private, the database in the private subnet. So let's select private EC2 instance. We want to connect to the the Aurora database engine only from the private EC2 instance, not from the public instance. So we do that, and so by default it is selected. The instance is from the private project VPC and the DB subnet group, and public access is no. We cannot do it because the if you remember the subnets that we selected for the DB subnet group, both of the subnets in the DB subnet group are in the private subnets. So they are not public subnets. So we cannot have public access to this one, and no point in having it. So we want to secure this one, and VPC security group. Let's create a new security group. Let's say Aurora security group, and new VPC security group. RDS EC2 1 will be added to enable connectivity with your compute resource. Just remember that, like I will show you, like this will be automatically created, and it will be attached to the instance. And additional configuration, database port is 3306, and authentication is using password authentication. Enhanced monitoring, for this demo we don't need it. I'm just going to unselect that one. And the additional configuration, and you can see that database options, and if you don't create an if you don't give a database name, the initial database will not be created. So let's create Aurora DB. Okay, let's do that. And I'm not going to change anything with a parameter group or cluster parameter group or DB parameter group or option group. So these are if you want to change the configuration for this Aurora, so you need to create a new parameter group or something that we need to attach it. But I'm not going to do that now, and I'm not going to change the failover priority. And the backup retention period, I'm just going to leave it as 1 day, and I'm going to have that encryption enabled by default using AWS schemas, and I'm just going to use the AWS RDS one, and backtrack. So this is a cool feature with Amazon Aurora compared to other RDS databases. If we need to if you want to create rollback, or if we anytime if you want to rewind, we can use, if you if you have enabled the backtrack, we don't have to create a new cluster altogether for any for any issues. We can just use backtrack with the same cluster instance. We can just go back in time, so we can before, if we have done something critical or damaging something, and if you want to go back, we can just do that. This is a cool feature. Backtrack lets you quickly rewind the DB cluster to a specific point in time without having to create another DB cluster. So for this demo, I don't need that, so I'm not going to select it. But this is a cool feature. Like in a production environment, you may want to do that for any issues, because you don't have to create a new cluster. You can just backtrack it. And I'm not going to do any log exports or anything. And maintenance, yeah, let us have enable auto miner version upgrade. And maintenance window, I don't have any preference at the moment. It's not a production one. And let's leave that deletion protection enabled. So by default, if you unselect this one, we can, if you by mistake, but if we do that not delete the instance, you should, that RDS will be deleted. That Aurora instance will be, database instance will be deleted, and it's better to have enabled this one. So if you want to delete it, you need to change that, come back and then disable that, and then only you will be able to delete the database engine. So this is good to have. Yeah, let's enable that one, and let's go ahead and create the database. So yeah, it's getting created now. It will take some time. Yep. So now it is creating my Aurora cluster, and a reader instance and a writer instance. So let's wait. I'll pause the video and come back once the instances are created, and then I'll show you how we can connect to this instance. Okay. Okay, now the Aurora database is created. Let me go ahead and clear the banner here. Okay, click on my cluster, and you have two endpoint names. One is the writer instance and one for the reader instance. See, the difference is it has a reader instance has RO, that is read only. So this is the global endpoint. So if you have multiple reader instances, we can select, if we select this one, it will connect to the instances, based on the priority. But if we want to connect to particular instance directly, you can select that instance. So this is the writer instance, and so we can use, this is not a global endpoint. This connects directly to this writer instance. Same way, if you select the reader instance, so it connects, if you use this endpoint, it directly connects to this reader instance directly instead of connecting from the global endpoint. Like so, if we use the advantage of using the global endpoint is like if one reader instance is maxed out, like if we cannot connect it, like if we use the global endpoint, like it will connect to the other reader instance. We don't have to go and change the endpoint. If some issue with the one reader instance, we don't have to go and change it to the other reader instance manually. So it's best to use the global endpoint. So let me go ahead and copy the endpoint name for the writer instance. Let me bring up my partition. Yeah, here we are now on my private EC2 instance, if you remember, and we have installed the SQL client. Now let's connect to the Aurora database. Let's see MySQL search for the host name and use this endpoint, and let's use the port, that is 3306, and the username is admin, and the password, I'm just going to give -p and then give enter. So it will ask for you the password. We can enter the password. We have connected to the Aurora database. We can just show the databases, and we have, also, like as in the when we created the Aurora cluster, we wanted to create that Aurora DB also, so that has been created here. And I was telling you, like when the instance Aurora database instance was created, like for the security groups, um, like it will create a security group and attach it to the private EC2 instance. And let me just quickly show you that. Let's go to EC2 instance, and the private EC2 instance is selected. Let's refresh the page here for a minute and then select the private EC2. And if you go to security, and we have now two security groups attached to it. Like if you remember, we only created private EC2 security group when we created that instance, but this is EC2 to RDS security group that is created when we created the Aurora database engine, and that gives access to the, when we selected the connectivity for EC2 instance, so it is attached to this private EC2 instance. So if you select this one, security group, and if you see the inbound role is nothing but outbound role, if you see it has that security group, uh, for connection to 3306 on port 3306. So we can connect to the Aurora database from the private EC2 instance, because that is going to be an outbound connection from private EC2 instance to the Aurora database engine. So that it is, this is for port range 3306 and MySQL Aurora type, and that has been enabled. And if you see this one, see, this is the one destination RDS EC21. So if you see, this security group is named EC2 to RDS, and there was another security group that is created, that is RDS to EC21, that is associated, attached to the Aurora database. If you go to the security group, if you select the RDS to EC21, so for this security group, there will be an inbound rule that is accepting connections from EC2 to RDS1. See, if you see from the source EC2 to RDS1, we are accepting connections on port 3306, and there is no outbound role. If you know security groups, or we can, if we don't have to enable the rules on inbound or outbound. If you allow the connection, so it is by default that connection outbound is also allowed. We don't have to have separate, like in network access control, like in NACL. So let's go back to RDS, and if you see that RDS security configuration, let's say subnet group is RDS is subnet group 1, and yeah, if it has a security group, 3 security groups, that the one that we created, Aurora security group, and RDS to EC2 security group. So this is the one that allows connection from the private EC2 instance to the Aurora database engine. So I think that's enough for this demo, and now you know how to create a custom VPC, and creating Aurora database and accessing it from a multi-tier architecture, like creating a bastion host on the public subnet, and creating private EC2 instance on the application layer, and creating Aurora database on the database layer, and how securely you can connect and access it. In my next video, I will show you how to migrate a database from MySQL to Aurora using a database migration service, Amazon DMS. Thank you.